in central orbit we get two type of problem. The first type is here the orbit is given, we have to find out the law of force or velocity or etc. But in the second type we have to given the law of force and we have to find or we have to calculate the central orbit by using some condition. And we here deal with the one first type problem. That is, we have to given a central orbit and we have to find the central force or law of force and find the velocity. And the first problem is, if the orbit is circular and the center of force on the circumference. Okay, this is circular orbit, this is the central orbit. It makes by an central force. We have to find the force. Okay, let a point O on the circumference, this is the center of force or law of force. Let this is the initial line as diameter OX, and at any point P, this is the position P and the coordinate is r theta at any time T. So the central force act along this line. Okay, along this line, and let it be capital P or we here let capital F. This is central force. We have to find this force. And we know that this is let C be the center of the circle. If this is P r theta, so this is theta and this is r, and we know that the equation of the circular path together with O as pole, that is the pole on the circumference, is given by r equal to 2a cos theta, where a be the radius of the circle. Right? Now we go to the polar differential equation of central orbit. d2u by d theta 2 plus u, this is equal to f by h square u square. Here u means 1 by r, this is 1 by 2a into sec theta. Right? Now we have to find du d theta. This is equal to 1 by 2a into sec theta tan theta. So this is again u, so we get du d theta, this is u tan theta. Now we find out d2u by d theta 2 and we get d2u by d theta 2, this is equal to du d theta into tan theta plus u sec square theta, and we put again here du d theta, this is u tan square theta plus u sec square theta, and this is u into tan square theta means sec square theta minus 1, so we get 2 sec square theta minus 1, and put this value as we get u into 2 sec square theta minus 1 plus 1, this is equal to f by h square u square, that is f, this is equal to h square u cube into 2 sec square theta. Now we put the value of sec theta. The value of sec theta is 2a into u whole square, that is 8 a square h square u to the power 5. So we write f proportional to u to the power 5 or f proportional to 1 by r to the power 5, and this is the law of force. So the central force inversely with fifth power of the distance of the particle from center of force or from O. Okay. We also know that the expression of velocity at any point in the central orbit as this is v square, this is equal to h square into u plus du d theta whole square. This is the expression of velocity. Sorry, this is u square. Now we put du d theta. This means du d theta means u tan theta. So we get h square into u square plus u square tan square theta, and this is h square into u square into sec square theta. Now we put the value of sec theta. This is 2au. So we get h square u square into 2au whole square. So we get this is 4a square h square u to the power 4. Hence the law of velocity or velocity is given by v square is proportional to u square, because this term is a constant and we write v is proportional to u. Sorry, this is not v square, this is u to the power 4. So this is u square, that is velocity is proportional to 1 by r square. That is the velocity is inversely proportional to the second power or inversely proportional to the square of the distance from the center of force of the particle, right? And this expression, these two expressions, this expression and this expression is also determined by the another differential equation, that is the Patra differential equation. How can find or derive this two expression by another differential equation? Let us see. To derive central force and velocity, we first draw a tangent at the point P, right? This is the tangent at the point P of the circle, and we draw a perpendicular from the pole or from the center of force, and we join P to the center of the circle. This is C. Since this is theta and this angle is also be theta, because these two are the same length A, and this is isosceles triangle, right? Now we know that at any point on the circle, the line choose the center from any point. This is always perpendicular to the tangent, and this is also we draw a perpendicular line on the tangent at T. So these two lines must be parallel. Okay. So by alternate angle formula we get this is theta and this also be theta. Okay. And from the differential calculus we get this length is small t. Okay, because this is the perpendicular on the tangent from the pole to the tangent at P. So this is taken to be P. Now from the triangle OP and this is N, we get P by R. P by R, this is base and this is hypotenuse and this is angle. So P by R, this is equal to cos theta, and we also get cos theta, this is equal to R by 2A. So P by R, this is equal to R by 2A, right? So P, this is equal to R square by 2A. That is R square equal to 2A into P. This is the pedal equation of the circle at that time, right? Now we have to find the force F, and we here differentiate P with respect to r, we get 2a dp dr, this is equal to 2r, that is dp dr, this is equal to r by a, right? And we put here the value of dp dr and we get f, this is equal to h square by pq into r by a, right? This is dp dr, this is r by a, and put the value of pq. Since p is this, so we get h square by r square by 2a whole cube into r by a, and this is 8aq h square by r to the power 5 into a, this is 8 a square h square by r to the power 5. So we get f is proportional to 1 by r to the power 5, and we get the central force F or the law of force very easily from the pedal equation. Clear? Now in pedal form we get the velocity expression. This is also very easy expression. This is Vp equal to h, and we get V, this is equal to h by p, and h by p means r square by 2a, that is 2ah by r square. So velocity proportional to 1 by r square. This is also very easy expression from the pedal form. Okay, so we derive the central force and the velocity at any point on the circular orbit, where the center of force lies on the circumference of the circle. Okay, this is the today's class. Thank you for watching.